This lesson is a continuation of multiplying polynomials. In your table of contents, you can title it as Special Products. Before we begin, warm up with these 4 problems. Pause the video, take approximately 10 minutes, then resume to check your work. Now that you're ready to continue, let's review these problems. In number 1, I'm going to use FOIL method. F-O-I-L. First, outside, inside, last. First, I'm going to multiply x times x, which gives me x squared. Then I'm going to multiply x times negative 1, which gives me negative x. Notice how I didn't put the 1. It's not necessary. Then I'm going to multiply 5 times x, which gives me a positive 5x. Then lastly, I have 5 times negative 1, which gives me negative 5. Before I move on, I want to make sure that I've combined all my like terms and then it's written in standard form. If you take a look, the x squared is written first, then negative x, and then 5x, then negative 5. These two in the middle can be combined since they have the same base, x, and a power of 1. So I have x squared plus 4x minus 5 as my final answer. In number 2, you cannot use FOIL method. It's a binomial times a trinomial, so the best thing to do here would be to distribute everything to everything or use box method. I'm just going to go ahead and distribute. First, I'm going to start with the x, so x times x squared gives me x cubed. Then x times 3x gives me 3x squared. Then x times 2 gives me 2x. Don't forget about the negative 5, also needs to be distributed to everything. Negative 5 times x squared is negative 5x squared. Negative 5 times 3x is going to give me negative 15x. Then negative 5 times 2 gives me negative 10. Again, don't forget to look and see if it's written in standard form, highest degree to lowest degree, and also to combine like terms along the way. X cubed looks like the highest degree. Then I have the 3x squared and the negative 5x squared, which are like terms, and my 2x and negative 15x, which are like terms as well. When I write my final answer, I would get x cubed minus 2x squared minus 13x, and then minus, minus 10 as my final answer. All right, moving forward, number 3 is a monomial times a monomial. I changed up how this looks because when we had it written as negative 2x cubed in parentheses and 5x squared, some people were getting confused. There's no plus sign here. All I'm doing is multiplying the coefficients, negative 2 times 5, and adding my exponents. When I multiply it out, whether it looks like this or this, multiply the coefficients, add the exponents. Negative 10x to the power of 5 would be my final answer. Alrighty, on to the next, number 4. Distribute negative 3x squared to 2x. That gives me negative 6x cubed. Then distribute negative 3 to the 4, negative 12, and carry the x squared with it. Here's my final answer here. Any questions or you need additional practice on any of these questions that we worked on last week, make sure that you reach out and I can give you some additional practice. Otherwise, let's move forward with the lesson. So as I mentioned in the beginning, we're going to talk about special products. We have 3 different situations. If you see them in a question, there is a rule you can follow if you start to understand and point out a pattern when you're multiplying polynomials that look like one of the following. First, we're going to look at perfect square trinomials, whether it has a plus sign or a minus sign in between the 2 terms, or the difference of 2 squares, which has a plus and a minus. So let's take a look at example number 1. example number 1 will be x plus 4 squared. X plus 4 squared, we have to understand that this is not x squared plus 4 squared, which gives me x squared plus 16. That is wrong. Do not think that way. We have to understand that a squared is when something is written twice. So for example, if I have 10 squared, I know that 10 squared is 100. How do I know it's 100 and not 20? Because it's 10 times 10. 10 times 10 is 100. So I have to use that same idea with this x plus 4. I need to write it twice so I know what I'm multiplying out. I have x plus 4, and then that's times x plus 4. When I FOIL this out or use box method, distribution, whatever you want to do, you would have something along the lines of x squared plus 4x plus 4x plus 16. Combine the two in the middle that are like terms, you would have x squared plus 8x plus 16. Now, if I know that this is a perfect squared trinomial, which I do know it is because it's x plus 4 squared, then there's a rule that you can follow for anything that resembles a perfect square trinomial. So if you have any such a plus b squared, the result is always going to be, like you saw on the screen, a squared plus 2ab plus b squared. Where did these ab's come from? Well, ab, again, is just a variable, just like x is just a variable. It places something that we're working with. So in this case, a is going to represent x, and b is going to represent 4. How do I know this? Well, my problem here is x plus 4 squared. So if you see vertically that a matches up with x and b matches up with 4. So a is going to be x and b is going to be 4. I'm going to work this out by using this rule, a squared plus 2ab plus b squared. A in this case is x, so I have x squared plus 2, a again is x, and b again is 4, plus 4 squared. Now if I clean all that up, I would have again something like x squared plus 8x plus 16. As you can see, that's what I got in the beginning. They're the same thing. So whether or not you know to write it twice or the perfect square trinomial special case, you still get the same answer. You don't have to use the special case rule. However, it helps you move along in solving these perfect situations quicker. But you're welcome to use FOIL or box as long as you know to write the x plus 4 squared or whatever situation you have twice. Let's look at another example. So let's say I have something like x plus 5 squared. Again, I have x plus 5 squared, so it's not written twice. I have to visualize this as written twice. Not x plus 5, x squared, and 5 squared, but x plus 5 times x plus 5. When I FOIL this out, I have x squared plus 5x plus 5x plus 25. Combine like terms, you have x squared plus 10x plus 25, and there's my answer. Now, if I think about this in terms of the perfect square trinomial, I know that the rule for anything that resembles a plus b squared is equal to a squared plus 2ab plus b squared. If I fill this in as a and b, I know that a is going to be x and b is going to be 5. You see how they're in their place. So in this case, I would have x squared plus 2 times a times b plus b squared, which is 5 squared. If I simplify and clean this up, I get x squared. I can multiply the 2 and the 5 to get 10x, and then I have 5 squared. 5 times 5 is 25. If you take a look here, my answers that I got when I FOILed versus when I used the perfect square trinomial rule is the exact same. Let's take a look at example number 3. Example number 3 will be something a little more complex. Let's say I have 3x plus 2y squared. Okay, so I'm not going to FOIL this one out, but if you want to FOIL and see if you're right, that's totally fine. I'm going to work this out by using the perfect square trinomial rule. I know this is a perfect square trinomial rule because it resembles a plus b squared. In this case, a is 3x and b is 2y. So when I use my a plus b squared, I know that the rule is whatever a squared is plus 2ab plus b squared. So if a is 3x, I'm going to do 3x squared plus 2 times whatever a is times whatever b is plus b squared in parentheses 2y squared. I have to put it in parentheses because I'm not just squaring 3 or x, I'm squaring the whole term. So don't forget that when you're simplifying this out, that the 2, the squared, goes to the 3 and the x. So this would be the same thing as 9x squared. If I clean this up here, it would be 2 times 3, which is 6, and then 6 times 2, which is 12. And then my letters x, y, alphabetical. I don't need to change the powers because they're not like bases. There's just one x and one y, so I leave it x, y. Plus, again, distribute the 2 to the 2 and the 2 to the y, the squared to the 2 and the 2 to the y. Plus 4y squared. And now I'm done. So let me know if you got that correct by doing a different method. It's totally fine, but you can use this shortcut to allow you to multiply. And the quicker you learn the shortcut, then you don't have to write that information there. You can just go from the problem to the solution. Okay, so let's take a look here at some practice problems. In our special products, this is situation number 1. So you can see they all resemble that a plus b squared. Go ahead and try 1 through 4 on your own and work them out. So our next situation that we're going to look at is the perfect square trinomial, but this time it will have a minus sign. So the second situation here is what we'll be looking at. Let's take a look at example number 1. Let's say example number 1 is x minus 3 squared. So again, we have that same 2 terms multiplied twice. So if I rewrite this, I'll have x minus 3 times x minus 3. Then when I FOIL this out, I have my x squared minus 3x, again minus 3x, and then a negative times a negative, you know, is a positive. So my final answer would be x squared minus 6x plus 9. So you can certainly use those methods you already know. However, if you want to use the shortcut, the perfect square trinomial rule when you have this situation is just slightly different than the previous. So if I have anything that is a minus b squared, it's always going to have the result of a squared minus 2ab plus whatever b squared is. So the only difference really is this minus sign compared to the previous problem. So in this example here, I have my x minus 3 squared. Again, a is here and b is here. So if I do a squared, that's going to give me x squared minus 2 times a, which is x, times b, which is 3, plus b squared, which is just 3 to the power of 2. Then I go ahead and work this out. I have my x squared minus, that would give me 6x plus 9. Here's my answer. Okay, let's take a look at example number 2. Example number 2 will be x minus 4 squared. So if I FOIL this out, I know that this is x minus 4 times x minus 4. And then I have my first term, x squared, negative 4x, and then plus 16. Combine, you have x squared minus 8x plus 16. Okay, back to the special product rule. If I have a minus b squared, I know that I'll get a squared minus 2ab plus b squared. So when I work that out, I would have my x minus 4 squared. A in this case is x and b in this case is 4. A would be x squared minus 2 times a times b plus b squared. Clean it up, I would have x squared minus 8x plus 16. There's that same answer I got by FOILing. Okay, let's take a look at a more complex example. So let's say I have something like 4x minus 3y squared. If I work this out, I know that when I have a minus b squared, I will get a squared minus a 2ab plus b squared. Okay, so I know in this case 4x is a and 3y is b. If I put them into their corresponding spots, don't forget to use parentheses because you have two items that you're squaring here, 4 and x, minus 2 times 4x, and then b is 3y plus the 3y squared. Okay, so then I have 16x squared. That would give me 8, and then 8 times 3 is 24, so minus 24 xy, and then I have 9y squared is my answer. So let me know if you used a different method, if you got the same thing, and that's fine. Again, you can use FOIL, you can use box, as long as you know that whenever you see this squared, you have to write the binomial twice. So 4x minus 3y and then 4x minus 3y again, or use this strategy, this quick tool to solve for the perfect square trinomial. Before we move forward, go ahead and take a look at the situation number 2 examples and see if you can try those out. So in our last special product situation, we have what's called the difference of two squares. The difference of two squares is different than the previous two examples in that you have a plus b and then an a minus b. So a and b might be the same number or same variable, but in between these two binomials, you have a plus sign and then a minus sign. So the result is going to look slightly different than our previous special product rules. Let's take a look at an example for when I have difference of two squares. So in our first example, let's take a look at something that says x plus 4 times x minus 4. So I know that this is going to be a difference of two squares situation because I have the same a and b values, then I have a plus and a minus, so they're different signs. If I FOIL this out like I know how to do before, I have x squared, and then I have minus 4x, and then plus 4x, and then minus 16. Okay, then when I combine like terms, something happens. I have a negative 4 and a positive 4. Negative 4 plus 4 is actually 0. So this whole situation in the middle is going to cancel out. It's 0. I don't need to write x because that would stand for 1x. I just cross it out and my final answer would be x squared minus 16. So if I have a situation that looks like as follows, if I have a plus b, and then I have the same thing, but it's a minus b, then I know that I'm going to get the following. I will have something that is whatever a squared is, minus whatever b squared is, okay? So if I know that I have x plus 4, and then I have x minus 4, x is a, and then b is 4. So I know that my result in the end is going to be x squared minus b, so b is 4 squared, and the end result would be x squared minus 16. Okay, so let's take a look at another example. Let's say I have something like 9 plus x, and then I have 9 minus x. Okay, so they're the same a value, 9 and 9, and then the same b value, x and x, and then I have a plus sign and a minus sign. So if I FOIL this out, I have 9 times 9, which is 81. Then I have negative 9x, and then I have plus 9x, and then I have negative x squared. Okay, when I combine like terms, I see something interesting here. Negative 9 and 9 make 0, so that actually cancels out, and I would have 81 minus x squared. And then you might be thinking, well, that's not in standard form, so perhaps I want to switch these around and write negative x squared plus 81 as my final answer. So I know this is a difference of two squares examples because I have an a plus b and an a minus b. So I know my answer is going to be whatever a squared is minus b squared. So if I know that a is 9 and b is x, my final answer would be whatever a 9 squared is minus b, which is x squared is. I can simplify and make that 81 minus x squared. And again, you can see that that's not in standard form, so I'd want to swap them around, x squared plus 81 as my final answer. Again, you can FOIL them out or box them, whatever method you want to use, but this is just a trick to help you with these 3 special cases. Okay, let's look at one more example. Let's say we have x squared plus 2y, and then x squared minus 2y. We've got a lot going on in this problem, but I know this is a special case because a matches here, x squared and x squared, and then 2y and 2y for b, and then I have a plus and a minus sign. So I know this is a special case. When I get a special case like this, I know that if I have a plus b and a minus b, it's going to be a squared minus b squared. Be careful with situations like this because there's a lot going on in the problem, so you want to make sure that you put the whole a in parentheses because you're squaring the whole a. So for example, if a is our x squared here, I would put x squared inside parentheses, and I still have the squared here on the outside. Then I have that minus sign, and my b value, which is 2y, goes inside parentheses, and that squared here goes outside. So don't forget that you're distributing that negative or that 2 into the x, right? So there's no number here. Well, 1 squared is 1, so that's going to stay. And then multiply here, that gives me 4. So that would be x to the power of 4. If you remember power to power rule in your little book of exponent rules, that's what rule this is. This is not addition, this is power to power. Okay, so then I have 2, I have to carry that power of 2 to this 2 and power of 2 to the y. So that's going to be minus whatever 2 squared is and then y squared. If I simplify and clean that up, I have x to the power of 4 minus 4y squared. Okay, so take a look at these examples here for situation number 3. See if you can work them out and let me know if you have any questions. If you haven't already done so, ensure that you've written this table down in your composition notebooks about special products. In the case that you're studying for your EOC, it would be helpful to know these application rules for special products so that when you're multiplying something that is a perfect square trinomial or the difference of two squares, you know the rule that applies to these specific special products. Before we move forward, we're going to look at some application problems. Application problem number 1 states that a designer adds a border with a uniform width to a square rug. The original side length of the rug is x minus 5 feet. The side length of the entire rug, including the original rug and the border, is x plus 5 feet. What is the area of the border? Then evaluate the area of the border if x equals 10 feet. So this type of question has two parts. To first find the area of the border, and then to plug 10 into whatever area that is to find a number of feet that represents the area of the border. It's really important that we understand some of the key words here. So if you can visualize what's going on, you have a border and then a rug around the border. So if you have a square rug, you know that a square has all equal sides. So if the original side length of the rug is x minus 5, then all side lengths of the original rug are x minus 5. I like to draw a picture when I'm doing these application problems, so maybe you want to do the same. I have a square rug, here's my square, and I know that all sides are x minus 5. All four sides are x minus 5. They're the same size. So if I wanted to find the area of a square rug, I know that I can find the area of this four-sided shape by multiplying the length times the width. Area equals length times width. So I know that all four sides are the same. I have x minus 5 and x minus 5 and x minus 5 and x minus 5. I only need two of them, the length and the width, to find the area. When I multiply them, I have my x minus 5 times x minus 5. If you notice, I have the same thing written twice. So I know that this is my special products rule that has to do with perfect square trinomials when there's a minus sign in between. If you remember the rule, you know that this will be whatever a squared is minus 2ab plus whatever b squared is. So if I know that a is x and b is 5, I can evaluate this using my perfect square trinomial rule. So in this case, x squared minus 2 times a times b plus b squared, okay? So I have x squared minus 10x plus 25. And this is just one part of this first section of the problem. If you go back to what the question says, it says the original side length of the rug is x minus 5 feet. Okay, so if I go back to the question, that's just the area of the original side of the rug. Now it says the side length of the entire rug, including this border that was added, is x plus 5 feet. So if I'm looking at this rug here, and I know that the original has a size of x minus 5, don't think too complex about this x minus 5 and x plus 5. What you need to visualize is what's going on here. It's a rug with a border around it. So I'll draw a border here around my rug, my square rug. Remember, a square has all equal sides. So there's this border here, right? Okay. And the size of this border is x plus 5. Let's go back to the question. So it says the side length of the entire rug, including the original rug and the border, is x plus 5. So all together here, it is x plus 5. So the area of the original rug inside and this pink border around it is now going to be x plus 5, okay? So if I find now the new area with the border around it, I'm going to again multiply it out by finding x plus 5 times x plus 5. If you see, it's the same thing written twice, so that's the same thing as saying x plus 5 squared, okay? And this is going to be my perfect square trinomial rule when I have a plus sign. If you remember that rule, it would be a squared plus 2ab plus b squared. In this case, a is x and b is 5. When I multiply this out, I have a, which is x squared, plus 2 times a times b plus b squared. Clean it up, x squared plus 10x plus 25. Okay, so I have my two situations here. This situation here represents the rug without, W-O, without border. And this situation here represents the area with border, W, with border. Okay, so if I just want to find the area of this pink space, I need to take away this area here, okay? So this is a subtraction problem. I want to take the original rug away, and I only want the area of the pink space. Okay, so if I set this up here, we'll have a entire border and rug together is x squared plus 10x plus 25. That's the border and the rug. Take away just the original rug, so that's that space that's in the middle, that's not shaded there, minus x squared minus 10x plus 25. So if you remember a few weeks ago how to subtract the polynomials, you're going to distribute this negative sign to everything over here. Then we have a new problem, x squared plus 10x plus 25, then minus x squared plus 10x and minus 25. Then I can go ahead and combine like terms to simplify this problem. So if I combine like terms, I know I have x squared minus x squared. Interesting. And then I have 10x and 10x. You can just go ahead and combine those right away. You don't have to do this middle step. And then I have my 25 minus 25. So plus 25 minus 25. All right, so then I'm going to evaluate that here. 1x squared minus 1x squared is actually 0. Cancels out. 10x plus 10x is 20x. And then I have 25 minus 25. Hey, that's 0 too, so that cancels out. That means that if I go back to the problems, make sure I answer the question, what is the area of the border? Let me pull it up again. What is the area of the border? The area of the border is 20x. Okay? Then it says evaluate the area of the border if x equals 10 feet. So if x equals 10 feet, then I want to know if I plug in 10, what will the result be? So go back to my problem here. I have 20x represents my area. Area of just the border is 20x. If I know that x equals 10, I can plug in 10 to 20, 10 for x, and then figure out what 20 times 10 is. 20 times 10, if I multiply, is 200. So I have an area of the border is 200, and I believe we were working in feet. Okay, so feet squared would be the final answer to my problem. All right, so if I go back here, make sure I answered. A designer adds a border with a uniform width of the square rug. The original side length is this, and then the side length of the entire rug, including the original rug of the border, is x plus 5. What is the area? So we multiplied and then subtract the original rug to get the area of just the border. Then we plugged in 10 feet to find the area of the border as a number, which was 20 feet. And now we finished the first application problem. Okay, so let's go back to the next application problem. The next application problem says a square patio has a side length of x minus 3 feet. Write an expression for the area of the patio. So again, we have that word square. So if you know a square has the same sides, then if one side length is x minus 3, you actually know that all four sides are x minus 3. Write an expression for the area. So if we know we're finding area, again, we're doing length times width. If I have one side, the length, then I also have the width, x minus 3. So if I have my situation here is my square patio, and I know it's x minus 3, then I know that all sides of the square are also x minus 3. If I go back to my rule, this is length, area is length times width. I know my length is x minus 3, so my width is also going to be x minus 3. I can FOIL that out or use my special perfect square trinomial rule. I know this will be, my area will be x minus 3 squared. So I know that if I have an a minus b squared, I'm going to get something that is a squared minus 2ab plus b squared. You don't have to write this rule every time. It's just helpful to see it. Then you can start to realize what the pattern is. So if a is x and b is 3, then I know that my final answer will be x squared minus 2 times x times 3 plus 3 squared, okay? So then I have x squared minus 6x plus 9. There's my area, okay? This question didn't ask me to plug in anything, so the area of my patio will be that final answer, which is x squared minus 6x plus 9, okay? So moving forward, that is the conclusion of the special products. So you can go ahead and complete the independent practice that is on HMH online. If you want to get an extra credit point, you can go ahead and make a comment on this question here. Try and see which student, what their mistakes were, and explain the student's mistake. If there's more than one or just one student, you can choose what to comment below and tell me the mistake that they made, okay?